Earth is hurtling through a cosmic battlefield. Each day, thousands of space rocks fly past our planet. Most pose no danger, but some could wipe out an entire metropolis or bring an end to human civilization. Until recently, we've been navigating this celestial hazard zone virtually blind. We're aware that the locations of most of these rocks remain unknown to us. That reality is changing at this very moment. A formidable new instrument has entered service. When scientists activated it for the first time in June 2025, it discovered 2,000 new asteroids within a single week. That's 2,000 potential dangers to life on Earth that have existed alongside us all this time, yet remained invisible until now. This is merely the start. This is the Vera C. Rubin Observatory. It's an enormous telescope, unlike anything we've encountered before. Positioned in the Atacama Desert in northern Chile, Rubin stands elevated above the cloud layer on a rugged mountain peak where the atmosphere is arid and the night skies rank among the darkest on the planet. At Rubin's heart lies a revolutionary piece of technology, the largest digital camera ever constructed. It's comparable in size to an SUV and carries similar weight. Where the newest iPhone features a 48-megapixel image sensor, Rubin boasts 3,200 megapixels, more than 66 times the resolution. It's not simply about capturing crisp photographs. With that level of capability, Rubin can identify objects so dim and distant that they wouldn't appear in any standard photograph. It's so capable that in theory it could detect a candle flame on the lunar surface. That's not the objective, however. This degree of resolution enables scientists to locate fast-moving asteroids, identify newly formed stars, and observe subtle transformations across galaxies. It's a scientific tool engineered to capture the tiniest movements across the largest field we've ever examined. Having an advanced camera is one matter, but the real distinction lies in how you employ it. Most telescopes produce a static photograph of the sky. Consider those stunning images you've viewed from James Webb and Hubble. They're extremely magnified telephoto captures of the universe that reveal all the intricate details. Rubin, by contrast, is more like a wide-angle panoramic ultra-high-definition video of the night sky in motion. Despite being situated here on Earth, it records the universe with a speed and scope we've never achieved before. Every few nights, Rubin surveys more than half of the observable sky. What it's generating is essentially a time-lapse of the cosmos. For scientists, this provides them with an entirely new capability to rewind, fast-forward, zoom in, and observe cosmic phenomena that unfold in real time. During its first 10 hours of test observations distributed across 7 nights, it identified more than 2,100 previously undiscovered asteroids. That total includes 7 near-Earth objects, indicating they have the potential to intersect our trajectory at some future point. Currently, we have knowledge of slightly over 1 million asteroids in our cosmic vicinity. Rubin is expected to discover nearly 1 million new objects annually for at least the next 5 years. Rubin isn't only monitoring asteroids. It's also detecting comets, including those originating from the depths of space. Its sensitivity enables it to spot faint tails and outgassing activity, assisting scientists in studying these frozen celestial wanderers. In reality, Rubin is likely to discover more comets than any previous observatory, supplementing discoveries like C2023A3 Atlas, a recent interstellar visitor detected in July 2025 by the Atlas survey. For those keeping track, this represents only the 3rd interstellar object from beyond our solar system ever monitored. Beyond asteroids and stars, Rubin is also seeking something more fundamental, the invisible framework of the universe called dark matter. By measuring how light curves around unseen mass, Rubin will chart this invisible substance with unprecedented precision. By monitoring how galaxies separate over time, it will help scientists comprehend the enigmatic force of dark energy that's thought to be accelerating cosmic expansion. That's actually the source of the observatory's name. Vera Florence Cooper Rubin was an American astronomer whose research on galaxy rotation is broadly recognized as the first proof for the presence of dark matter in the universe. She died in 2016 at the age of 88. Here's the telescope's operating principle. Its camera employs 6 specialized glass filters that can be quickly swapped each time a new image is captured. Each filter isolates specific wavelengths of light from infrared to ultraviolet, and then generates layers in the image that enable scientists to distinguish the youngest or most remote galaxies. The primary mirror is a distinctive fusion of 2 designs, almost resembling an inverted sombrero, measuring 8.4 meters in diameter. It's been polished so precisely that its surface is smooth to within 1/50th the thickness of a human hair. Rubin actually contains 3 mirrors and 3 corrective lenses that function together to gather, focus, and sharpen every particle of light before it reaches the camera. The observatory utilizes these special LED lights to continuously recalibrate the mirror alignment and compensate for any minor variations that might develop over time. This camera requires more than just lenses and filters to achieve what it achieves. The image sensor must be maintained at extremely cold temperatures to function. We're discussing temperatures approaching -100 degrees Celsius. Without the cryogenic cooling, much of the data would be obscured by thermal noise. Despite its considerable weight, the telescope is so perfectly balanced that it can be moved by hand. When repositioned, it settles almost immediately with no residual movement. That stability permits Rubin to capture sharp images quickly and repeatedly, which is essential to creating these panoramic images. The telescope must be repositioned multiple times each night. All told, this observatory required over 20 years and $700 million to construct. It was a global collaboration led by the U.S. National Science Foundation and the U.S. Department of Energy. What we're witnessing right now is just the commencement of Vera Rubin's first decade-long observation campaign called the Legacy Survey of Space and Time. As concerned as we are about monitoring asteroids throughout the solar system, we recognize that there's also a challenge with unknown objects much nearer to home. The Jeff Bezos-owned Blue Origin has formed a partnership with a small company called Scout Space to make Earth orbit a safer environment using artificial intelligence. This is a new mission that was just announced to fly on Blue Origin's New Glenn rocket in 2026. It's going to be the first genuine test of the company's Blue Ring spacecraft, which is a type of orbital transit system that the company has been developing. Blue Ring would be capable of traveling between multiple destinations in Earth orbit, and it can transport up to 13 payloads simultaneously with a capacity of up to 4 metric tons. It can be utilized for deploying different satellites at varying altitudes, refueling operations, or even relocating existing satellites from one position to another. It can even travel to the Moon or Mars. A Pathfinder variant of Blue Ring was tested on the inaugural launch of the New Glenn rocket in January 2025. The test payload was designed to validate the spacecraft's mechanical systems and navigation. For its first actual operation, Blue Ring is going to deliver the Scout Space Owl sensor to geostationary orbit more than 35,000 kilometers above the Earth. From that elevated vantage point, Owl is going to employ artificial intelligence to detect, monitor, and characterize objects in orbit, including satellites, debris, and other floating material, whether man-made or natural. This is what we call space domain awareness, or SDA, and it becomes increasingly important as we launch more objects into orbit. We've only recently started deploying massive constellations of internet satellites. That's in addition to navigation satellites, observation satellites, and now it appears that missile defense is the next mega constellation that's scheduled to be launched. The concept is that instead of people attempting to monitor all this material, we position these autonomous AI sensors above the entire situation to maintain surveillance, like vigilant owls. Speaking of enigmatic objects we place into Earth orbit, the U.S. Space Force is preparing for another launch of their X-37 reusable spaceplane. This would mark the 8th flight of the Boeing-manufactured autonomous vehicle, and it's scheduled to lift off from Florida on a SpaceX Falcon 9 rocket. That's somewhat notable because the last time an X-37 flew, it required a Falcon Heavy launch to reach an exceptionally high Earth orbit, but it's not returning there this time. What's most intriguing about the X-37 is that it spends remarkably long durations in orbit conducting mysterious classified operations. Between May 2020 and November 2022, the vehicle spent 908 days in space. We know that it deploys satellites and performs experiments while it's in orbit. Typically, these fall within the realm of Air Force research and defense innovation. We've been informed that payloads on this mission will include a laser communications demonstration and something called a quantum inertial sensor, which aims to address the challenge of maintaining precise navigation when GPS signals are unavailable or compromised. It's essentially the U.S. military leveraging the launch capabilities of SpaceX to maintain a substantial advantage over every other nation regarding defense infrastructure in Earth orbit, which is logical. No other rocket can launch as rapidly and as frequently as Falcon 9. For the most part, America can do whatever they desire in space, and no one else can rival them. However, competition is increasing. The Chinese actually possess their own version of the X-37 spaceplane. It's called the Shenlong, or Divine Dragon. It launched for the first time in 2020 and returned to land on Earth 2 days later. Then it launched again in 2022 and spent 276 days in orbit. The most recent launch occurred in December 2023, with a return in September 2024. As limited as our knowledge is about the Boeing X-37, we know even less about the Shenlong, or what precisely the Chinese are using it for. Theories range from experimenting with hypersonic missile technology to essentially just replicating the Americans for the sake of replicating the Americans simply to demonstrate that they can. If you enjoyed the video, then you might consider becoming a channel member here on YouTube, and we're introducing a new member perk to enhance the offer. Channel members now receive early exclusive access to our custom-built 3D renderings. You also get to see what we all look like in real life and future benefits that remain undetermined but will probably be quite impressive. Regardless, if you enjoy the channel and you want to support us, this is a truly excellent way to help us continue to produce bigger, better videos for you. Be sure to check the link down below in the description and join today.